Hello everyone. Let's go through assignment number 9. In this assignment, we are trying to practice with how to find the generating function of a sequence. So for part A, this sequence is given by finding the terms like this from 0 to infinity, and each term is the constant -1. In order to write the generating function, I need you to write the series and also say, if I write the extended one, how it looks like. I don't need the final answer as the closed form because we need several theorems for that, several definitions. And since the exam, the final exam will be online, so it doesn't make sense in terms of evaluation because you can simply find the formula on internet. So these two parts are the most important, and I want to show you for all of the items that how you can provide the final answer for each of them. So we have the constant, and if you remember, the formula was like this. We should provide a series an, or in the theorem we wrote k instead of n, and x power n, and n should start from 0 and goes to infinity. And sometimes it's not the case that we have infinite number of terms. We can stop at an upper bound. So for part A, an is actually -1. This is a constant. So I can write n from 0 to infinity -1 x n. So this is the formula that you can use for generating your function. So whatever you see as an, you just put it in front of your series, and that's pretty easy. And xn, and you write the final answer as the extended version. So it means that just assign values of n starting from 0. It means that minus x power 0 minus x power 1 minus x power 2, and this one goes to infinity. And for the first term, you can write -1 minus x minus x2, and it goes to infinity. So you don't need to provide the closed form here, because this one is the final answer. Of course, it's nice to know about them. If you like, you can find the final answer as the closed form on internet, but we are not going to ask it on the final exam. So for part B, now instead of -1, I have 2 power n. The challenge here is that for the first term, I have a0 equal to 0, so it doesn't follow this format. So how can I deal with that when I write the series? So this one is different from the other items, and we should be careful about item B, because I write, for example, 2n xn, but I should be careful. It starts from 1 instead of 0, goes to infinity. What about the term a0 equal to 0? In that case, beside this series, I should consider also n equal to 0 case as well, because this one is related to our theorem. We should start from here. So here I should write a0 and x power 0. It's like instead of defining a series from n equal to 0 going to infinity, I define it like this now, to consider the 0 case for n in a separate term. Because if I wanted to put 0 here and don't include this part, then it doesn't follow this formula because 2 power 0 is 1, which gives us a different answer. So when I write the extended part, first write this part, which is 0 multiply x power 0. The whole term, as you know, is 0 multiply 1, which is 0, plus, now starting from the series. Now what we have is, starting from 1, we have 2 power 1 multiply x power 1 plus 2 power 2 x power 2 and continue to infinity. So what we have is 0 plus 2x plus 4x power 2 goes to infinity, and you can write 2x 4x power 2 plus going to infinity, and this is the final answer. The thing is that it's not always this extra term is 0. Assume that this one was equal to 2. Then if you provide such an answer, it doesn't make any sense. We should be careful about it. 2 power 2 x2 plus, for example, suddenly a constant here. To provide such answer is not meaningful. That's why I'm telling you, these extra terms that you find beside your series, write them first, okay? Then when you put these 3 dots, it understands that it follows a trend. So we should avoid such a solution here. So C here is 0, for example, doesn't make any difference, but anyway, we should be careful about these things. Now for part C. Now instead of a power n, we have n minus 1. This is pretty easy, but anyway, I'm going to write them for all of them. So with no problem, everything starts from 0 when this is the case. Right away, I can insert these values, n minus 1 and x power n. So this one will be equal to, so if I insert 0, this would be minus x power 0. Then if it, n will be 1, we will have 0 multiplying x power 1 plus. Then we will have 2 here, so 1 multiply x power 2, and you continue like that. So as the final answer, you can write here, this is minus 1, this one is 0. So what you have is plus x power 2. And it's not bad to continue the trend. Like check it for n equal to 3. So it will be 2 x power 3, and then put these 3 dots to show the trend. Next one, for part D. Now here we have factorial. So here I start from 0 to infinity with no problem. How do I understand this is infinity? You see, we have dots here. It continues. So for all of them, we have the same scenario. If it stops at the term, it's okay. If it's, for example, we say 0, 1, 2, 3, 4, 5, then you stop at 5 at our series as well. We should be careful about these things too. We practiced it in one of the examples inside our lecture. But for all of these examples that you can see here, it goes to infinity. That's why here we have infinity on my series. So here I write 1 over n plus 1 factorial x power n. So this one is also easy. You just insert n instead of, assign the values of n one by one. So first one is 0. So this is 1 factorial, which is 1 itself. And this one is power 0. Now instead of n, I will have 1. So 1 plus 1 factorial x1 plus 1 over 2 instead of n, and you continue. So you can write the final answer like here you have 1 here, 1 factorial is 1, so you will have 1, here you have 1, so 1 plus 2 factorial, this is 2 multiply 1, which is 1 over 2, x, plus, here you have 3 factorial, which means 3 multiply 2 multiply 1, which is 6, so 1 over 6, x power 2. So that's what we mean by generating function. And of course, there exists closed form, which is compact, which is brief, and that one we usually use in mathematics. But as long as you write this part, it shows me that you know how to define the generating function. For item E, so all of them are pretty much the same. So I mean, for item E and F, they are pretty the same. So if you know how to deal with one of them, you know the other one. So let me deal with E. For sure, if you know how to solve E, you know how to solve F item as well. So let me go through part E. Now, assume AN to be equal to this combination. You already know what's the definition of combination. So here for generating function, again, I started from 0 goes to infinity. You see, 0 goes to infinity. Okay. Then AN is 2 from n combination. And here we have x power n, of course, for all of them. So when I start assigning n values, we will have here, by the way, here we can face a problem here because this value, as you know, it should be at least 2. Otherwise, we cannot define it, right? So what's happening here is that for the terms 0 to infinity, the 0 to 1, I cannot define it. That will be problematic. So what I can say is that instead of making equality, I say that implies. You see that definition of these things are important, because if you write equal, it doesn't make any sense. Because for those n equal to 0 and n equal to 1, you cannot define. So this one implies that since I cannot define for n0 and n1, because these two cannot be included, so I can start my series from 2. Because those two are not equal to 0. If you write 0, it doesn't make any sense. So the series should start from 2. And here, what we do, by the way, it's not a bad idea to talk about f, because here also it could be some limitations, so it's not a bad idea. I go through that one too for you. Anyway, so here for item E, starting from 2, going to infinity, now this formula makes sense. X power n. So now this one is equal to 2 out of 2, x power 2. You see, it doesn't start from 0 now. It starts from 2. Plus, now we have 3, 2, and x 3, and you continue. So I write the final answer here. You should write the extended format. So extended format, it means that you just summarize, not summarizing, I mean extending your solution as much as possible. So it means that when you have combination, you should write what this one means. It means that 2 factorial, you remember the formula, right? You had r out of n. You already have that formula. So n minus r means that 2 minus 2 factorial, and r factorial, which is 2 factorial. This one is x2 plus, again, the same formula, 3 factorial. We will have 3 minus 2 factorial. You see why we didn't start from 0? Because here we would have negative, and negative factorial doesn't exist. We didn't define such a case, so we cannot say that. And here, 2 factorial x3, and you continue. So what you will have, you can calculate these ones, and that's it. That would be the final answer. So 2 over 2 factorial, which is 2 multiply 1, over here 0 factorial is 1 as we define it. You remember 0 factorial is always equal to 1. So here we have again 0 factorial, which is 1 multiply 2 factorial, which is 2 multiply 1. The whole thing is 1. So x2 plus, for this one, here 1 factorial, here we have 3 factorial, 2 factorial. As you know, here you can write 3 multiply 2 multiply 1. Here you have 2 multiply 1. So these two will be eliminated, and what you have is 3. Or you could write 3 multiply 2 factorial, and 2 factorials will be eliminated with each other. You already know how to deal with them. They are pretty basic. So 3x3, and you continue until infinity. It is possible for n now to go to infinity with no problem. But personally, I would prefer to stop the series at n, because it could be somehow problematic for finding the combination, because it is meaningless to, for example, find 2 out of infinity combination. But anyway, because we will have the vague situation. When we have vague situation, then personally I would prefer to not to go into infinity and stop it at the term instead of infinity n. But you don't want to mention that. That's good enough for me. If you mention about this part, that's good enough for me. But just remember that the infinity case could be problematic for you too. Okay, for this one. Here we have both of them are combination. Of course, if you know how to deal with the previous one, you get idea about this one. But here for this term, it is fixed. But here for n plus 1, it is not. It is related to n. So here, let's start without knowing the restrictions that we have here first, then we will fix it. So n is starting from 0. And first I write infinity here as well. And here I write the formula 10n plus 1 and x power n. The thing is that, as you know, if I have n r in the combination, r cannot be bigger than n. So we will have a restriction. So instead of equality here, I say this one implies, since I cannot have values from which part? Let's see from which part. N should be 9, and after 9 it could not be defined. Like if I have n equal to 10, it will be 11 here. So 11 out of 10 is not possible. That's why my n cannot be bigger than 9. This is not possible. So what I write here is here 9 here on the upper bound of my series. These things we should be careful. You see, guys, I didn't want to talk about it to make it a challenge for you, but since we are practicing, okay, let's go through this one as well. I also mentioned about this one. There's another extra things I would like to mention, but let me finish this part and I will mention that one. So, by the way, why I put division, we are talking about combination. Okay, so fix this one. I meant n plus 1 combination out of 10. So here I would have 10 n plus 1 x power n. Now let's write the extended version. It means that 10, 1, sorry, starting from, yes, 0, you assign it and you will have 1, and you will have x 0 plus. Whenever you want to write a trend, let me also talk about it because this is important. Because when I write the trend like 1, 2, going to infinity, I understand about the trend, right? It means that 1, 2, 3, 4 until infinity. So 2 terms are usually, they are usually good enough. Sometimes it's more complex, then 3 could be good enough. It depends. Here in this scenario, we have also upper bound. Whenever you have upper bound, I usually suggest you guys to consider 2 first terms, put 3 dots, and show me the last term to show me the trend. If you just show me the first and the last one, it doesn't make any sense, okay? Something like that. So in this one, we are starting from 0. 0 case, 1 case, going to the 9th case, for example. So when I want to show the extended formula for the generating function, I write the first, I write n equal to 1, which will be 2 here, x power 2, x power 1, we are considering the case 1, plus going to not infinity because we said it's not possible. So what I will have here is the case 9. When I put 9 here instead of n, what I get? 10. And here x power n. Okay, we should be careful about it. And for the final answer, again, you know how to deal with the combination. Just write the part related to this combination, like what we did in the previous example, and provide the final answer. Another thing I want you guys to be careful about, let me see if we have a space. Let me talk about it here. Okay, not always the sequence that we are defining is like defined by an and the trend of n. As you know from the previous lectures, we have different types of representing our sequences. Like, you know about recursion, so we can define our sequences recursively. So assume that this is the case and I want to define my sequences recursively, and based on that I want to define my generating function. How is it possible? So assume that recursively I define an plus 1 equal to an each term plus 2. You see each term. You can put parentheses so that we understand this 2 is not related to this index. And this one, as you know, we should define the initial one. Otherwise, the complete recursive definition is not completed. I was also restricted about this part in your midterm exam. For example, you may miss some points because of this. Just to let you know that this is very important to define our initial value for our sequences when you define them recursively very carefully. So here, assume that I define my A0 as -1. So, or maybe I can also start it from 1. Why not? Okay, starting from 1. So it means that if I want to write the terms of my sequence and it goes to infinity, then I started from 1. Then what is A1? A1 is 1 plus 2, which is 3. Then again, next one, you add 2 to it and goes to infinity. And here also, when you define a sequence recursively, you should be careful. You define this one a0 to equal to 1. Then here, what is the value, possible values for n here? N can be values starting from 1. Okay, so it means that when n is equal to 0, you have this case. When n is more than 1, you have this case. This is the best way to define a sequence recursively. So you already know about these things from your midterm. But how about, instead of such questions like these items which are given to you, A, B, C, D, E, F, here. Now I give you another item which includes a recursive definition of a sequence. Can you provide the generating function using the same theorem? So this is the one that I want to talk briefly, but you guys, you should practice with it, because you know about recursion, you know about generating function, you know about this specific theorem, so you should be able to deal with such question in the final exam as well. By the way, before going through that, let me mention about this theorem that we keep using in our book. This is called theorem 1 in this section. And for item EF, or the ones that you have some limitations like that, sometimes it's not correct to use this theorem for them. But as practicing, we are doing that. And because I don't want to go through all the theorems, it will make things complicated. I want you guys to practice with one. If you understand the topic related to one, of course, it's possible by reading other sections of the book, then you will have no problem dealing with them to learn about them. So let's focus on this theorem only, even if it is not compatible with some sequences. Just try to provide the answer based on the definition I've given you. Then the rest will be easy as well. So for this sequence, now assume that I've given you this sequence recursively. How to find the generating function? Then it's not possible to write the sigma a n plus 2 x power n. It doesn't have any meaning. What is a n here? Again, you didn't define it, so it's meaningless. So in order to put it in front of the summation, to define it as a series. So what I should do is to convert this recursive sequence to a normal sequence, as you can see here. If you do that, the rest is easy. You can deal with that. So it means that you should find a trend like this. I understood the trend is 1, 3, 5 going to infinity. We are talking about positive odd numbers. So you should find about the terms an. How can I write the an part? So easily you can define it by 2n plus 1. And n can get value starting from 0, 1, 2, goes to infinity. You see? So you should be able to convert such sequences like this. For some of them are easy, like the one that you saw. For some of them, you need, for example, some theorems in order to solve them. And we already practiced with one of them, Fibonacci numbers. You remember how I changed the Fibonacci numbers and find the explicit formula for that? When we talked about explicit formula, it means that you can define it like this. So this is also another challenge you should be careful about. In the previous assignment, we practiced with that. So sometimes we may ask you about finding the generating function for recursive sequences. You should be careful first to convert them into such standard normal, such a standard definition of sequences, and then provide me the generating function. So if you have this information, now it's easy for you to find the generating function, right? You just put this one in front of the summation, and it starts from 0, goes to infinity, and x power n in front of it. Okay, guys, if you have any questions, please let me know. As you know, on Friday, it will be the New Year, so we won't have an online session on Friday, but I will record the videos for you. At least one video related to your lecture, and there will be some extra videos for your next week. I also uploaded them before, which are not related to our final exam topic, that one, but as you know, graphs will be included in your final exam, but lecture 13 and 14 are not included. So we will talk about them later, but for the timing, if you have any question about the assignment or our course, please let me know. And I wish all of you guys a happy new year in advance.